And welcome back to another segment of your advanced math notes. We are talking about transforming the sine and cosine waves, but now we're going to incorporate not just vertical transformations, but all of them. So the basic format of our transformations within the equation are the same as they've always been. Things that are inside parentheses affect the graph horizontally, and kind of opposite from what we see. So if we have a coefficient of, let's say, 2 here, that means that instead of multiplying all of our x's by 2, we would divide all of our x's by 2. If we're adding a number here, that means that we would shift the graph to the left, or we would subtract that value from our x's instead of adding. Things that happen outside the grouping symbols, like this and this, affect things vertically, and it's straightforward. And that I'm not going to talk about too much because we talked about it in the previous notes. So this basic structure for the graph transformations hopefully looks very familiar to you. This applies, it's written with the sine function, but this applies to cosine as well. And when we get to them, the other trig functions, secant, cosecant, tangent, and cotangent also. So if you remember, we have some specific vocabulary when talking about trig functions. Because trig functions repeat over and over again in the same very predictable, repeatable way, we have what's called a period, meaning the number of x values that it takes for the graph to repeat itself. So going from a max to a max or a min to a min would be one way to measure your period. With sine and cosine, the period is always 2 pi specifically. Now that we could be transforming the graph, we're going to calculate horizontally, I should say. The period could change. We could compress it or stretch it horizontally. And so to calculate the period now, what we'll do is we'll take 2 pi and we will divide it by the k value, and we should specifically say the absolute value of the k value, meaning we're always going to divide it by the positive number. A negative number here and here do not indicate anything except reflecting. We'll talk more about that in a minute. But so now to calculate the period for sine and cosine, if we have a horizontal dilation, we'll take the original period, 2 pi, and divide it by the positive k value. Amplitude, or the height of our wave, is given by the vertical dilation, and the amplitude is again always positive because it's a distance or it's a height. So even if this is negative, it's only indicating a reflection, not a change in the amplitude. And then if we shift the graph to the left or to the right, with sine and cosine graphs, or with any trig graphs, we're going to call that a phase shift. And that is going to come from the c value, or the number that we're adding or subtracting is just a horizontal shift. And then the vertical shift we talked about yesterday is anything outside the parentheses that we add or subtract, and it's straightforward. Okay, so you should recognize what the placement of the different values will do to your graph. You should know which variable it will affect and how it will affect it mathematically. So just to be clear, we should jot this down. Remember that if A is negative, it doesn't change the amplitude. The amplitude is always positive, and it's always whatever this number is, the absolute value of it. The negative value just indicates a vertical reflection or a reflection across the x-axis, meaning we're going to negate all of our y values or change their signs. There's a couple of things we need to talk about here. Horizontal transformations are always a little bit trickier. Okay, please note that you're not always going to get your equation in factored form. So your kx and your c will be grouped together in this set of parentheses. But if you have both a k and a c value, you will need to make sure that you factor it out if it's not already given to you in factored form. So you'll have a nested set of parentheses within your original set of parentheses. If you don't do that, your phase shift will be off. So please keep that in mind and make sure that you do that. Anything, again, horizontally is going to affect the x's. And remember, if your k value is negative, it doesn't mean anything other than a reflection across the y-axis or a horizontal reflection, meaning you're going to negate all of your x values. But if there's no c value present, sometimes you won't see a set of parentheses. So if you're not adding or subtracting anything, then you won't always see a set of parentheses. It's the location of the k value that indicates it's a horizontal transformation or dilation specifically, as opposed to a vertical one. Vertical dilations occur right before they're the coefficient on your trig function, whereas horizontal transformations are the coefficient on your x term. So you won't always see parentheses there. Just know that the location of it is what indicates the horizontal transformation. And that is kind of it. We're going to be sort of putting all of these together and having to graph sine and cosine with a lot of different types of transformations apply to it, and be able to find the amplitude, period, vertical shift, phase shift, the minimum point, the maximum point potentially, the midline points, maybe x or y intercepts, things like that. So come to class with any questions that you guys have, and we're going to do a lot of practice on it.